Hello students. Today we're going to talk about functions in Python. A function is a named sequence of statements that are grouped together. Functions are defined by using a function definition, which follows the standard format of the keyword def, def, followed by the name of the function, followed by a list of parameters, this can be 0 or more, and then a single colon. Inside the function, we have one or more lines of code called statements, and these are indented. It's worth noting that the function name must follow standard Python naming conventions. This means that you can use any word that starts with an alphabetical letter and contains letters, underscores, or numbers. By convention, functions generally start with a lowercase letter. There can be any number of statements greater than 0 within a function. This can create a compound statement which consists of a header and a code block. The header, in this case, is the function definition, and the code block is the statements that are contained within it. In the event that you need to create a function that doesn't have any code in it, you can simply use the keyword pass. This acts as a single line of code, and it doesn't do anything. When the Python interpreter encounters the keyword pass, it simply moves on to the next line. The keyword for a function definition is def. This marks it as a function definition and must be at the outermost level of indentation. The parameter list is a list of values the function needs to have in order to do its job. Some functions don't require any parameters, and so they don't need any information to be sent in. If you do need information to be sent in, you can create a parameter for each piece of information that you want to send into your function. So let's consider a simple program that implements a drawStar function using turtles. We can start by setting up our program. We import the turtle module, and we can create a screen and a turtle, and we'll call our turtle Jose. The code for drawing a star might look something like this. We have a for loop. It says for I in range 5, we move Jose forward 100 units, and then turn right 144 degrees. To turn this into a function, we can start out with a function definition. We'll use the keyword def and then the name of our function, in this case drawStar. And then we have our parameter list. In this case, we want the drawStar function to be able to be used with any turtle and to draw a star of any size. So we can add two parameters to our parameter list. The first is some turtle that we want to use, and the second is the size that we want to pass in. When we create a parameter in this way, the parameter takes on the value of whatever is sent in to the function when it's called, and is assigned that value as a variable. So in this case, we've created the variable tert and the variable size, and when we call the function, we'll assign those variables values. We can then use those variables in our code. So we can repeat the code from the previous slide. In this case, we have our for loop, and then we have the turtle move forward according to our size, and then turn right 144 degrees. Now, make a note that we are using the turtle that was passed in and the size parameter that was passed in, rather than having these statically coded. Once we've created the function, we need to invoke it. The function header must match the format of the function call. In this case, our function header is this line of code. It says drawStar, it says turtle size. In this case, we have two parameters, and so when we make the function call, we must include both. Our function call will look something like you see here. The keyword, or the function name drawStar, followed by the turtle we want to pass in, and the size of the star we want to draw. Our completed code looks something like this. The advantage of this is that we can now draw a new star with whatever size we want, or with another turtle if we wanted to, with a single line of code, and we could reuse this code. It also allows us to logically organize the code in such a way that we can give it a meaningful name. And these are the key reasons that we use functions. By naming a function something that's meaningful to us, we can logically organize all the code for some specific task, and only put the code that's relevant to that task in the function, thereby separating it out from other sections of our code. This will help make debugging easier, as well as a number of other, help us keep track of code in large projects. Second, functions allow us to reuse code. Now that we have a drawStar function, we can draw stars of many different sizes and with different turtles, and we only need to invoke our function each time rather than repeating all of the code. Docstrings are another thing I want to talk about today. Docstrings are a special tool in Python to help document your code. If the first line after a function header is a triple quoted string, that string is called a docstring and gets special treatment. It is used to generate documentation or get help about how a function works. For example, for our drawStar function, we could create the following docstring. We'll make the turtle turt draw a square, or excuse me, this should say draw a star with a side of a certain size. And so in this case, when someone looks for help for the drawStar function, or when they start to type it into the Python idle editor, they'll get this message back saying this is how this function works. Now we've talked a little bit about parameters, but let's talk a little bit about arguments. Parameters are the list of variables in a function definition that state what the function needs in order to operate. Arguments are the list of variables in the function call that match those parameters. Some functions take many arguments. For example, the max function can take any number of numeric values and returns to the highest value that's sent in. There's also a special statement that terminates a function. This is called the return statement. The return statement sends back some value to the function call. It's often the last line in a function call, and when the return statement is encountered, the function call will terminate. Not all functions need a return value, but many do. In the case of our drawStar function, for example, it was not necessary to include a return value. So let's consider an example of this. Let's create a simple function that squares some numeric value. We'll call this square, and we can create this using a function declaration like you see on the slide. We'll create a new variable y. We'll take the parameter x, multiply it by itself, and store the value of that multiplication in y, and then return the value y. In this case, what's happening is it's the place where the function square is invoked can be thought of as the value y in this case. So for example, if we take the value 10 and we want to find the square of 10, we'll say the result is equal to square to square. In this case, we pass in the value 10 as our parameter, and all of this code runs, and the entire function call is replaced by the return value, in this case y, or 100, which is then stored in the value result. We can then use a print statement to find out what value is stored there, as well as format our output nicely. Scoping is an important concept within Python programming. When code is contained within a code block, whether it's in a function, a for loop, or elsewhere, it's scoped within that block. Excuse me, sorry about that. When code is contained within a code block, whether in a function, a for loop, or elsewhere, it's scoped within that block. Variables that are created within a code block are destroyed when the code block is terminated. What this means is that variables that you create within a function cannot be used after that function terminates, whether it runs out of code to use or it encounters a return statement. Variables should be created and used only in the code block that they're needed in. Scoping in Python follows a hierarchy, which coincidentally matches indentation. First, local variables are used, variables created with the current code block. After we're out of local variables, we shift up one level of indentation or one level of scope and check for variables there. These are called global variables. Global variables generally refer to variables that can be used anywhere in a program, but the idea is that any variable that's not created within the scope of a specific code block is global to that code block. In the event that two variables have the same name, they will follow this hierarchy, so local variables will be used first, before global variables. Now that we've talked a little bit about functions, I want to talk a little bit about one way that we can use a for loop to create some interesting behaviors. And this is called the accumulator pattern. The accumulator pattern is a special way to use variables to keep a running total of how many times something has occurred or some other value. The accumulator is initialized in the global scope to some base value, usually 0. Each time an event occurs, the accumulator is incremented. We can then check the value of the accumulator to determine how many times that event has occurred. So in this example, we create a simple accumulator variable and set that equal to 0. We can then use a for loop, and within the for loop, take the accumulator variable and set it equal to its current value plus 1. What this will do is cause it to increment each time the for loop is executed. Here we can see a piece of code that would use an accumulator pattern to perform the square function that we talked about earlier. In this case, we create a new variable called running total, and we set this equal to 0. We then use a for loop and say we want to iterate through this for loop x number of times. We're then going to take a running total and add the current value of the running total, the value of x. So in this case, if we pass in 10, for example, the first time through the loop, running total is equal to 0, and we add 10 to that value. The second time through the loop, running total is now equal to 10, and we add 10 more, which makes it equal to 20. And we do this x times, which is 10 times, and the result is that we have x times, which is, again, the definition of squaring the value. Now, some final notes about functions. It's important to note that a program can contain many functions. Generally, functions are defined at the beginning of a program before code is ever run. It's also worth noting that one function can call another function as long as they've already been defined. This leads to a very useful concept called decomposition. We can break down a program into different functions where each function does exactly what it needs to do and nothing more. Each function should be focused and specific, and we should only add a new function when we want to do something new. This is tremendously useful when we go through the process of debugging, and we're trying to figure out where an error in our code is. We can look at the bug we're encountering and then use the behaviors that we're seeing surrounding that bug to figure out where in the code that bug exists. Now, one very useful technique is to use a main function. In this case, we create a function that contains all of the program's code and then you invoke that function at the end of the program. The main function is responsible for handling the logical flow of control through the rest of the program. Often, you'll use a main function that contains very little logic. Instead, it invokes other functions which contain the appropriate logic. This is a key idea in the idea of incremental development. Now, we've mentioned incremental development briefly in the past, but incremental development is the idea that we only add code in small increments. We break the problem into the smallest and simplest problems first, and then we solve one problem at a time. Once we have that problem solved, we move on to the next step in the larger problem. Once we've solved the simplest problem, we test and we move on to the next. And we find whatever of the remaining problems, what's the simplest, we solve it, we test, and we move on to the next. Each time we do this, we'll be either adding a new function if the simplest problem is new behaviors, or we'll be changing how another function already works. The idea is always that you start small, you make incremental changes, you test often, and you refactor your code or rewrite your code to make it cleaner after you're done. Having seen that functions can call one another, there are many techniques we can use now. One of the most important is called composition. Composition means using other functions to expand the flexibility of a function you're writing.